Hi everyone. For those of you who don't know me, my name is Bruno Alvicio and I am a software engineer. I have recorded this video to give you a demo of a feature that I have been working on for the last few months. But before I get to the demo, I would like to give you a brief introduction of what hypervisors are. Let me open first this Wikipedia article that talks about hypervisors. Basically, hypervisor is computer software that allows a user to create and run virtual machines. There are different types of hypervisors and it's a very broad topic. And you may actually be familiar with some hypervisor like VMware or VirtualBox. You might have used them in a previous project. Let me focus on now on this diagram that explains how all the pieces come together. Here at the bottom of the stack we have the hardware, which basically represents the physical components that make up the computer. On top of that hardware we have the hypervisor running, that's a software, and on top of that hypervisor we have the different virtual machines with its operating systems, and basically that's how everything comes together. Finally, I would like to mention two terms that I am going to be using repeatedly during this video. One is host machines, which are the computers on which the hypervisor runs. And the second are virtual machines, which are also called guest machines. If we go back to this diagram, here the hardware plus the hypervisor would represent the host machine, and these would represent the guest machines. One feature of hypervisors is what is commonly referred as live virtual machine migration. In a nutshell, live virtual machine migration is the ability to move virtual machines from one host machine to another host. As we can see in the diagram, there is one VM running on the host computer on the left. Now, hypervisors allow the user to move this VM to another host computer. It is important to note that from the virtual machine user's perspective though, nothing is happening and the VM continues running uninterrupted. However, a current limitation of some hypervisors is that for this migration to be possible, the VM has to have network storage. That is, the disk of the VM is not on the host machine, but in another third remote computer. My work was to remove this limitation of needing network storage for a particular hypervisor called Xen. I have adapted the migration algorithm used by Xen so that now virtual machines which have their disk in the host can now be migrated too. I am now back in Wikipedia. There is an article that is dedicated to the Xen Hypervisor, so for those of you who are interested, you can read more about it here. Xen is an open source hypervisor and it is supported by the Linux Foundation. It supports different architectures such as x86 and ARM. Xen actually started around 13 or 14 years ago at the University of Cambridge, and since then the project really took off and it is now being used by many companies such as Oracle, Citrix and Intel. Here is the Xen project official website where you can find more technical information, news, links to instruction manuals and to the actual source code. So that was the background information that I wanted to give you, and now I will start the demo. Here we have two machines running the Debian operating system with Xen installed. I have named them Debian Xen 1 and Debian Xen 2. What I am going to do is to create a virtual machine with its disk in Debian Xen 1 and then migrate it to Debian Xen 2. To prove that the data was moved from one computer to the other, I will enter the virtual machine and create a text file inside the virtual machine before migrating it. I will then migrate the virtual machine, and then after it is done, I will enter the VM again, but this time from Debian Xen 2, and confirm that we can also see the file there. To create the VM, I use a configuration file where I specify to the hypervisor what attributes I want the virtual machine to have. Let me show you how that configuration file looks like. The first parameter is the name that I'm going to be assigning to the virtual machine, in this case, tinycore. The second parameter is the disk parameter, which in this case points to a file in the host machine. This means that the virtual machine is going to have local storage instead of network storage. I will start the VM using a program called Xen, and this will tell the Xen Hypervisor to create a new VM using the configuration file I just showed you. So now I'm going to type Xen create tinycore.config. Press enter, and now the virtual machine has been created. To check that, I'm going to use another command called Xen list. Xen list is going to return a list of all the virtual machines that are currently running in this host. Here we can see tinycore with its ID of 13, and then here shows the state of the virtual machines. In this case, R stands for running. Now I'm going to access the VM using a VNC connection. You don't really need to know what a VNC connection is, but what it allows me to do is to see a visual display of the virtual machine I have just created. So this is the console of the virtual machine. I'm going to list all the files in this folder. There are none, so I'm going to create a new file. I am going to call it demo.txt, and then I'm going to write a short message. Migration is cool. I'm going to save this file, and now when I do a list again on this directory, I see that the demo.txt file is there. If I print the file, the message I just wrote is there. I'm going to now exit the VM, go back to Debian Xen 1 and issue the migrate command. For that again, I'm going to use Xen, and this time Xen migrate. Then I'm going to specify the flag that tells the hypervisor migrate this VM with its local disk too. And this is the feature that I have been working on for the last few months. Then I'm going to say specify which VM I want to migrate, in this case tinycore we want to migrate, and where. For that, I'm going to write the IP address of Debian Xen 2, which is 10.32.81.35. I hit enter. It's going to ask me for the password. Hit enter again. And now the migration has started. These are logs printed by the Xen and the hypervisor, which give us information about the progress of the migration. It's going to take a little while because it's not only copying the virtual machine memory but also all the data in the disk. So we can wait a little bit, and also I can now do an Xen list command in Debian Xen 2, the host machine that is receiving the VM, and here we can already see that the tinycore is incoming to this host machine. Here, take a look at these two logs. These two logs mean that these were when the disk copying started, and this was logged when the disk copy finished. So now we have to wait a little bit more until the migration is done. Also, we can see that the state of the VM is paused because it's still not running. Okay, great. Here, this log means that the migration has finished. So we can do an Xen list again on the destination host machine. Now tinycore is in Debian Xen 2 and it is running. B also means that the VM is running. And also we can check that it is gone from Debian Xen 1. So now we do list in Xen list in Debian Xen 1 and tinycore is not there, right? So now, finally, to conclude this demo, I'm going to access tinycore again using the VNC connection, but this time from Debian Xen 2, since now it's running in Debian Xen 2. And again, I'm going to list the VM. Now the VM is running. I see the demo.txt file, and we can also print that file, and we see the message that we wrote back when the VM was running in Debian Xen 1. So that's basically everything I wanted to show you today. And I think also give you an introduction in the world of virtualization, which I think it's really cool. A few caveats about this feature is that it's still by no means production ready. And what I mean by that is that even though I have just showed you that it works, it's not a stable feature yet. There is a lot of work to be done in the case something fails during the migration process so that we don't lose any data. There is also work to be done to improve the performance of the feature to make it faster. Finally, there is work to do to integrate this feature to the official version of Xen. Also, for those of you who are interested and want to help me, I have uploaded all the code that I have written in the last few months to my GitHub account. So, and let me just show you that. So my GitHub account is in, of course, github.com/Valdicio, and it's inside the Xen project. This is my branch, and I have created a branch called QEMU disk migration, where all the changes that I have made are there. So you can send me your pull requests, and if they look good, I will be happy to accept them. That is all that I wanted to show you today. Hopefully you like this video, and please share it with your friends and give your thumbs up. Until next time.